Starting the recording for me, so happy Garbage Day, everyone. If you're celebrating Garbage Day today, I know that other people celebrate on different days or don't even know when their trash is picked up, which is the best part because then you don't have to worry about it. So I have several things open here. This is sort of our wrap up of Unit 1 is what I have planned today. We have a formative assessment to go over, and I did look at those this morning, did not provide a lot of feedback because we're going to go over it as a group here. So to do that, I built a Word document that has the questions, so we can walk through the logic and the code and do that together. I also sent an email out, I think on Friday, that I was inspired to come up with some real-world examples of research questions that have moderation as part of the ideas. So we're going to do that, and then whatever time we have left, we'll finish up with example 1. Got through most of that. So have you started looking at homework 1 by chance? You folks have? How's it going so far? Not going? No comments?
I got the first 2. Right?
Excellent.
That's as far as I've gotten.
No, but the first 2, do not downplay that because that means you imported the data correctly. You got your setup going. Like just getting started sometimes can be really overwhelming. So getting the first 2 questions, that's excellent. Does anyone have homework questions for me yet? Yes.
There was one particular thing that troubles me the most. It was question either 8 or 9
8 or 9.
in the homework.
Well, how about I pull it up? So I will be person 1 here so that I can look at this. Oh, apparently I didn't type enough ones.
Oh, it's question 8.
Okay, there we go. I did update grades this morning, by the way, so you all have your 2 points for doing the assignment. Question 8. Oh, yes, I've already answered a question about this one. So let me give an orientation to the homework and then I'll answer your question about it. So the story here is, like all my homeworks, loosely based on a true story. This is an examining the effect of various training types on mini golf performance. So where this story came from was the first time that I met my husband Jonathan's family. He's from California. We went out to play mini golf, and I had never seen such cutthroat mini golf trash talking amongst him and his sisters. Like, they take this shit seriously. So that was a very eye-opening experience about competitive mini golf. Last winter, we went mini golfing when we were in Hilton Head over break, and we actually tied. I finally tied him. Like, that's never happened before, and I was so proud of myself. But then another time, we were mini golfing with my family, and my dad, who plays golf, insisted that his golf game was interfering with his mini golf game. That sounded a little sus to me, but I was like, all right, Dad. So that was the basis of the story here, how we may have interference effects in different types of golf training. And more to your point, this is an example of a moderation problem where I have 4 groups as one categorical predictor being moderated by another quantitative variable and with another covariate in the model. So directly related to the examples we've been working with in the homework, it's 1 extra group rather than 4 instead of 3. So I'm hoping that you can extrapolate a little bit from the example. It won't work exactly, but you can start there as a starting point. So the instructions tell you how to code your variables in terms of who should be the reference group, the centering points for the other predictors, troubleshooting tips, and then we have 3 models. So usually it will be 1 model per section, but not always, and then any specific instructions. So starting with an empty model, for instance, I asked for the residual variance and the intercept, and then there's a spot down here where you can then interpret what those mean. And I really do recommend completing these drop-down sections right when you finish getting the answers, because otherwise you can get confused as to which model you're actually interpreting if you go back and do it later. So I would do those right away. So the question that we had was in a model that has training group as a set of predictors and experience, and additively predicting mini golf after controlling for enthusiasm. So 3 predictors in the model. 1 I'm thinking of as sort of a covariate that I don't care about, but the other 2 I'm interested in. So the question you are on is enter the F value for the significance test of the omnibus main effect of training group. So what is your question about that question? How or what or?
I mean, it's just kind of strange because all the values I'm getting, it end up showing green for all the other answers but this one.
So if you have residual variance correct, then you know you have the right model in terms of what predictors and what outcome. If you have the fixed intercept correct, you know that you have the right coding for all your predictors, the right reference group, the right centering points. So that's all good. Some of these things are going to be directly given in your output, and some of them are not. Question 8 and question 9, the p-value that goes with it, are examples of things that are not given by default, and that you'll have to look through the example to figure out how to ask for it. I will tell you that a synonym for omnibus test is slopes lumped together. Because there are 4 groups, it takes 3 slopes to differentiate them. So the question is asking for a joint hypothesis test of those 3 slopes. And there's various ways to ask for that in any software package. I gave you one way that will work across all the different types of models. You may also be able to do it. Are you using R or Stata? R. So I think potentially you could do it via an ANOVA command with a drop filter thing. But the way that I did it was with GLHT in the example. So that's one that will not show up by default unless you explicitly list it as a factor variable and ask, I think, through that. Sure.
Could you talk about the question 28?
28. So moving down into the big model. So this is section 3 is asking for the extent to which the effect of training depends on prior experience. Depends on is a word that signals an interaction term. To what extent does the effect of this predictor depend on another predictor? Think interaction, think moderation. And so this is a longer set of questions. Some of these are things that are showing up directly in your output, but most of them will not. They're things you will have to ask for via linear combinations. And we have, for instance, this one right here, 28?
27.
27,
Yeah.
okay. Standard error. Did you get 26 right?
Yeah.
Okay, that's interesting. How did you find 26, which is the estimate for the fixed slope of experience specifically in the mini golf group?
Minus 5.8.
So that you did the math manually with the output?
Yeah.
Okay, you will need to write, what package are you in? What, R, Stata, or
R,
SAS?
yeah.
R, okay. You can use GLHT to ask for that model implied slope, and if you do it that way, you will get not only the estimate that should match what you already have correct in 26, but you'll get the standard error and a hypothesis test for it, which you will need later on to answer the questions about whether each of the slopes was significant or not.
Oh, got it.
So I think it's helpful when you're first learning how to work these things that you used logic to get this right? So like you know what it should be.
Yeah.
That way, if you like, you know if your R code is working if you get that number back. But the logic, there are formulas by which you could compute the standard error, but I would not recommend doing that manually. To keep enough precision, I would let the computer do it.
I see.
Yep. Okay. Other questions?
Can I ask the concept of residual variance? Because I found that word coming through the entire homework, and I got confused because, like, for example, when you see question, what was it? Question number 1, it starts with residual variance.
Yes.
And at first I got it wrong, so I tried different tries. I mean, I'm using Stata, so
Okay.
the table shows standard deviation.
Yes. So
and
let's.
at first I just
Look at
typed the number of standard deviation, and it says it's wrong. So
Yeah.
I tried it again. So sometimes the table shows standard deviation, and sometimes it shows sum of squares and mean of sum of squares. So
Ah.
yeah.
So okay. The reason that I ask for a residual variance is because that will tell you if you have the right model. Like that's one number that is tied to the solution. Once we get into the generalized models for the rest of the class, that number is going to be a different quantity called -2 log likelihood. And that is also like a signet. It's like a fingerprint essentially for your model. Like it's unique enough to where like there's no other way to get to that. Conceptually, what residual variance means is the amount of the variability in your outcome that is left over after prediction by your model. So in this example right here, residual variance is this number, the 88. MS, this stands for mean square. And this is residual, stands for residual. So this is, because it's sums of squares for everything that's left in y, the difference between what you said y was and what it actually is, divided by the number of slopes you could have had. So then this number is a variance, and this is residual variance specifically of the e's. So in Stata, it will, in linear models like this, it will be in this table, in this spot always. And then most of the other things you need that pertain to the model as a whole, like the F value and the P value, are in this table as well. In R, you have to do a little bit more detective work because it's not printed by default. Instead, what it gives you is residual standard error, which is the square root of residual variance. So I added an ANOVA call right here just to get that number, which shows up in the very last row as mean square of the residuals. So there's the same 88. Does that help? Or not yet?
Yeah, that helps.
That helps.
For the bottom question, but for the question number 1, so in that sense, just type standard deviation on the table tells me that it's wrong. So you want to square the standard deviation for question number 1.
So
What's that?
I'm not sure why you would have standard deviations, because the sums of squares table is always phrased in squared units. What piece of output are you looking at for this?
So I went through it over the weekend, so I don't remember really.
Fair enough.
correctly, But I thought when I tried to solve this question, I did some of the descriptive analysis first.
Ah,
So that's
you went
why
that
the
way.
table shows, standard deviation. So
Gotcha.
I make it scared.
yes.
And I got it right, so I was like, oh, should
Yeah.
I do that?
Yeah,
every time?
so are you using Stata?
Yep.
Okay, so summarize the variable comma detail,
Mhm.
then it includes variance. You don't have to do the math.
Can you say that again?
Yes. So in Stata, the command for descriptive statistics for continuous variables is summarize, and then you type the name of the variable, and then a comma, which distinguishes options, and then detail or details. It's one of the two.
Detail or details.
Yeah, whichever one doesn't
Okay,
yell
I'll
at you,
try.
that's the right one, and then it will
Oh.
take that.
Okay, got
You
it.
can summarize multiple
Yeah.
quantitative variables, so.
Yeah, so you get, like, if you don't do detail, you get a small table that looks like this. If you do detail, you get a whole pile of stuff, and the variance is one of the things in the big
Yeah,
pile.
I guess I just typed some and variable name. So yeah, I'll put it detail too.
Yes, but my intent was for you to get it out of the model, even though conceptually it's the same idea. Because the empty model represents like the jumping off point for prediction. Its job is to recreate the mean and the variance of the outcome, but then the mean that is predicted becomes conditional on the predictors, and then the variance should decrease.
Thank you.
Sure. Okay, what else can I tell you about golf? Other than that I'm bad at it, the real kind at least. Well, I will keep asking. You have until next Monday to work on this. We've covered everything that you need to be able to do it. In terms of strategy, I want to talk a little bit about code and show you what my original code looks like for this handout that we've been building. So yeah, I'm going a little out of order, but since, come here. since we started talking about it, let me see if I can blow this thing up. Yes, I can. So I'll show you the Stata file and then I'll show you the R file. So in terms of code, keeping your file organized is going to be really helpful to you, and it will be helpful to us who are trying to help you troubleshoot when things go wrong. So like as a general principle, any variable transformations that I'm eventually going to need, I do front and center at the top. That way I don't have to hunt and find pieces of code that do variable transformations. I can have everything in one fell swoop. I always add labels because that's good documentation. R doesn't like you to have labels under certain packages, and so I always add them as comments. I know, it yells at you if you have labels. Like, what the hell? Like, seriously. I use these like little divider sections in whatever comment the package uses to try to have sections. So like, for instance, this is descriptives. This is one section of commands. And so note, this is all for one model. And then I have the next model and so on. So when you're going through and solving these things, I would not erase what you've done, right? Like I would put in a comment, section 1, leave your model, copy that and paste it below, and then add stuff to it. Like you want to have a complete record of all the steps that you took to answer things. And for homeworks that get very in-depth, like this one where I have a bunch of different questions, it can be helpful, like for all of these, for instance, all these lincoms in here, these are linear combinations of things. You might add to your comment, like this is question 29, right? Like literally write it in there, like do yourself a favor. That way when you're going back to figure out which slope is significant for which question, like you have something in writing to help you keep track of all of that. I do the same thing in R. So Nikki, anything you want to add about that, or Vladimir?
No, that's okay.
I have a recommendation for,
Let me show that
Lisa
R.
was just talking about the comment feature.
Mm-hmm.
What I often do is I have kind of those section breaks that Lisa was talking about, but I also take the exact text that Lisa puts as like, this is what
Comment.
this model is supposed to be doing and comment it out. So like section 1 for the homework is estimate a MD needs model, like I put that instruction literally in my homework file, so then when I'm like, we did an example of this, I can just, you'll save
Yeah.
your future self, is what I'm
Yeah.
saying.
And also, like, I would change my old comments. Like, don't leave them in there, because then you're going to look back at this thing and be like, what does dementia group have to do with this homework? And be like, it doesn't. That was from the other data set. So the comments will help your future self, but it also help you keep track of things as you're going. Same thing in R. So the structure of my R files, I always have the packages first, and if you ever want me to run things, you will need to have the packages being loaded as part of that. So I've seen that before, where people do that separately. That makes it so that I can't follow and reproduce your work. And the way that I have these is so that if you don't have it installed, it installs it for you and loads it. So that's why I do it this way, to make it so that if you haven't used it before, you don't have to go and find it. Same principle, I define my working directory this way, which is a little bit different because I like to have everything in the code and not click buttons to do things. But the same premise, I do all the variable creation steps first. Here are the labels and comments. And then I have, the signposty things, like this could be section 1, section 2, and all the models here. So I have it sort of separated into chunks, like I have a label that I use a print command for so that it shows up on the output that you guys get. Otherwise it doesn't. Comments don't show up on the text output. And then so it's what am I intending to do is first, and then what it's doing is next. So it's like intent, action, intent, action. And I find that to be helpful even when I'm not building teaching materials, because usually I can remember how to do things, but not why I did something. Like, why did I merge at this step? Why did I make this variable? What is this going to be used for? Like, that sort of motivational comments can be helpful. So then I also liberally use these things too to make a visual separator. That way when you're scrolling, you can find things a little bit more easily. So this is the side, the unwritten curriculum, I think they call it, like things that don't actually get taught anywhere. Future you will appreciate that. So if there's anything that we can help with respect to troubleshooting code or making your life easier in executing this, please let us know. We're happy to do that. So any thoughts or questions on that?
I just want to lift up what you were saying, because very often am I like coding completely from scratch. So use this comment away so it's easier to find stuff.
Yep. Yeah, so when you're doing your homework, don't go from the PDF handout, start from here. Because I've found that sometimes in the PDF handout, extra characters get copied and they're not visible, and then your code won't work. Also, sometimes like my comments turn regular apostrophes into curly versions, and like that will throw up, SAS can't handle that, for instance. Like little things like that. So start from the source files if you're going to copy things over to use as a template, which is my intent. Okay, so shall we talk about formative assessments? Shall we? Not rhetorical? So the first question is one that is a real life question. So I'm on the Facebook. I'm not on the Instagram or anything else because I just hang out with the rest of the olds. You know, we try to stay in our lane, put pictures up of our kids and things like that. But part of the face group communities that I'm involved with is the Psych Methods discussion group, the M+ group, and a few others like that. I also sometimes try to answer questions from graduate students within the forums that I'm part of for that. And one time I got involved in an exchange where people were asking what they should do in order to generate a model to predict something. And one of the commenters decided to tell them that regression is for prediction, whereas ANOVA is for testing mean differences. So how do you think I responded to that question? Because yeah, I can't let that go. And what would you have said? We got some inconsistent responses here, so I'm interested in the discussion. How would you answer this question about what to do? Is that statement correct? Incomplete? Incomplete?
Or I guess a little bit of both. So regression is used when you have continuous predictors,
Mm-hmm.
whereas ANOVA is used with categorical predictors typically. And
Yes.
so you can use ANOVA to test mean differences between groups because you have the categorical predictors, but it's not limited to just that.
Yes, regression is a broader framework. When people say regression, what they're typically talking about is standard multiple linear regression with quantitative predictors. But ANOVA is within the family of regression. If you think of it from a general perspective, if you put in a categorical predictor via dummy codes, that is an ANOVA. And you can have any kind of predictor variable you want in whatever combination as main effects, interaction terms, and so forth. So you can test mean differences in regression. It's just a synonym. Furthermore, what if you're interested in both? What if you have continuous predictors and group differences? Are you still doing prediction if you fit those into a regression model? Yeah. Even if you think of ANOVA as regression, like our golf homework, if I were to just put golf groups in the model, some people would call that an ANOVA, but I am predicting. I am predicting based on your group membership what your outcome is. That's regression. So there's an artificial distinction here that Cohen wrote about in like 1950 or something. And that was the point at which it became the general model, because that was like the most general thing at the time they could think of. And now that's just a special subcase of the world of more general, because then the word's generalized. So yeah, I think this comment is not helpful because this is an artificial distinction. These names of making models have different names based on what kind of predictors, that's not a thing anywhere else outside of just this one special case of general linear models. So other questions though, what else might you want to know about this person's data before you would advise them on how to generate a prediction model or test mean differences? What types of sampling designs are general linear models for?
Random sampling.
Random? How many dimensions of sampling? One, yeah, like across people of some kind usually, but not necessarily people. Could be animals or communities or businesses or states or stuff like that. But yeah, across one. So what if this person is trying to do prediction in a longitudinal study? Should they do regression or ANOVA? When they're sampling over time and people? The answer is none of the above. Then we need to add some adjectives in front of this. We need a multi-level regression, for instance, in which the difference is that there's two kinds of E's at a minimum, one for the people and one for the occasions. What else are we assuming, essentially, that regression and ANOVA would be right? What kind of outcome in my simple random sample? These models are for what kind of outcome in terms of how it's measured? Continuous. Yeah. What if I wanted to do a prediction model for the likelihood that I'm going to get COVID again this year? Could I do that? Can I do that with regression? Badly, I could, but not advised. So if you want to do a prediction of a not normal outcome, then we need a generalized version of a regression or an ANOVA. What if I want to predict the probability of getting COVID over time in a longitudinal study? Can I do that? Sure I can. So then we got to stack up both the adjectives. Then we would need multi-level and generalized in front of the regression. So those are the things that are much more important in terms of deciding how you would analyze data. This is an arbitrary distinction that you don't need to retain. That was my answer, essentially. Anything you want to add to that? Anything I'm forgetting? No? All right, the next ones are story problems we're going to work on together, so I'm going to temporarily skip ahead. And thank you for all providing your theme songs. I built you an unlisted YouTube playlist, and I put a link to it in icon under announcements. It's unlisted, which means that we can get to it with the link, but it's not publicly searchable. And I have not yet listened to everything, because I try to do that when I'm not actually trying to get stuff done. And this morning was a get stuff done kind of morning. But I thought I'd share my theme song with you. This year I picked California Love. And I did that for several reasons, most of which have to do with my husband, Jonathan. He works for this program, if you don't know him. He is having the best week ever. He is living his best life this week because he is a lifetime 49er fan, and they're going to the Super Bowl this weekend. They're playing the Chiefs, which is my family's lifetime plan. Like, it's going to be a whole thing. And he just got a new car, and then he had to get a new phone because CarPlay didn't work on his old phone in the new car. So he's like in a great mood this week. If you ever need something like this, is the week to ask. However, next week, he might be your guest host for this class, because next Tuesday is when I'm supposed to be in jury duty. So I find out Monday night if I actually have to go, and he is going to deliver this class for me if I have to go. So there will be a new Zoom link for his room, but otherwise it will be about the same, and you will be in very good hands. If my effort to be academic Karen and not get chosen is unsuccessful, if they end up picking me, I don't know what's going to happen after that. I'll have to see how long of a trial it is and all of those things. But the class will go on in some way, shape, or form. That I promise you, okay? But I can be really unpleasant when I want to be, so I'm really hopeful that that's enough to get me out of it and not get picked. But we'll see. All right. So formative assessment 1. I thought we could go over it and write out the stuff together, and I can post this after class. How does that sound? So you have a record. I don't normally post answer keys per se, but for algorithmic things like this, I think it's useful. So this is the equation that I had given you. I have 4 different predictors in it, labeled F, G, H, and I, because why not? And I asked for a couple of things related to this. So write the equation for a predicted outcome for a person with these values of their predictors. And then I had also suggested trying to write out a programming statement that would generate that prediction for you. There's various ways to do that, but we can use the same combination of linear combination of fixed effects that we've used for simple slopes and other things. So I'm going to actually write the equation. Do you all know how to do this in in Word, I should say? Alt equal sign. Also, insert menu has it, okay? So it says type equation here. I'm going to zoom in so you can watch me type, because this is one of those things that they never teach you, right? So y is the outcome I'm predicting. I'm going to keep my subscripts, so you can type LaTeX commands in here. So I'm going to hit the underscore key and then an I, like that, and then I hit the space bar and it becomes a subscript. If I wanted to have y, like y squared or something like that, if I do the caret above the 6 and a 2 and hit the space bar, then I have a superscript. So it goes much faster than hunting and pecking through all the symbols. You can do both at the same time. So for instance, if I do, I'm putting a slash, the one that's above the enter, I don't ever remember the names, backslash or forward slash, the one above the enter, that one. Yeah, like if it's backwards or forwards is just a matter of which way you're looking at it, right? So that's not helpful. But you can type Greek letters this way. So I'd hit slash and then sigma. Note that it's lowercase s and I hit space and it turns into the character. Then I can do caret 2, hit space, sub E, hit space, and then it's all there. I didn't invent it, but Jonathan taught me how to do this, actually. If you want to have Greek letters that are capital, like this, capital sigma, then it's that one instead. So, very cool. So let's put the equation in here properly, because it looks nice in your papers if you do it the nice way. So y equals, and because I am a little bit lazy, we're going to start with copying and pasting here. You also don't want to spend all of my time.
Efficient. You're not being lazy, you're being efficient.
Okay, sure. We'll go with that. But you're not paying valuable tuition dollars to sit here and watch me type, so we're going to minimize that. All right, so there's my equation. That's how my model gives me the prediction for any combination of my predictors. So if I want to generate a prediction for someone of an f of 2, where does 2 go? And this is not meant to be a trick question. Do not think too hard.
Into FI.
Yeah, I need to put it there. Anywhere else?
In the interaction.
Yeah, that one. And that one. G is 3. Where does 3 go? Yep. There it is. There it is. H is 4. I was trying to be nice. And I is 5. So note what is being changed and what is not. It's the things with i's that are being changed. Those are your variables that vary over individuals. That's what we're filling in. The betas stay exactly as they are. They don't have i's. They are fixed effects, and they apply to every case. So this is how the model tells me what the predicted outcome would be for this person. If I were to do this in Stata, I could do this in a number of ways, but I have lincom as one. So in lincom, I think there's no t. Is there a t? There's no t. Underscore const is how you talk about beta 0. So I need that plus the variable that beta 1 was for, which was f times 2, plus the next one, which was g times 3. So in the programming statements, it works a little bit differently because what the letters mean are the betas. The words, the names of the variables refer to the betas in these programming statements, and then the number is the value you would actually give for that variable. So if I finish this off here, we've got 4 was h, so h times 4 plus I times 5 plus, let's see here, that was f times g times, is that right? Yeah. 5. Nope, 6. That's what multiplication does, Lisa. I told you I don't do math in front of y'all. There's a reason for that. F and H, right? Times there. Now, does my equation over here need an E on it? Because I have an E up here. If I'm generating the prediction for someone with this profile of values, do I need the E? Do not. Because anybody who has these values has the same prediction. E represents the difference between the prediction and what they actually have for a specific individual, not just somebody with this profile. In R, there are various ways to do this as well, but if I go with the interior of one of those annoying sets of numbers, I need in the first spot a 1, because what is implied here but not written is that beta 0 is multiplied by 1. The second spot gets a 2, the third spot gets a 3, then a 4, then a 5, then a 6, then an 8. And that inside a GLHT command will give me that predicted value. There are much faster ways to do it, but this is helpful, I think, in understanding how the commands work. Okay, how are we doing?
Lisa, I have a question
Please.
for the Stata income there.
Mm-hmm.
So for beta 5 and beta 6, we are talking about interaction terms, and what I remember is we are using pound sign.
Oh, thank you.
So
Yes, I was in the wrong package.
okay then.
Yeah, it's stars in SAS and SPSS, it's pound in Stata, and it's colon in R if you're referring to just the interaction term.
Oh,
So I've got all of those in my head at once. Thank
yeah.
you for
Got
the
it,
correction.
thank
You were absolutely right. Okay, other questions or any of that you want to hear again? Should we move on to the next one? Predicted slope. I'm going to grab all my ingredients up here that I could possibly need to get my predicted slope. So I asked for the predicted f-slope for somebody with g of 3, h of 4, and I of 5. Okay, here's my ingredients, here's my model. What's step 1 in finding the predicted slope for the variable f? 3-step process.
Find where f is.
Find where f is, correct. So do I need beta 0? No. Do I need beta 1? Do I need beta 2? This is where people get tripped up because they're like, but it needs to be for g of 3. But that doesn't matter because I'm asking for the f slope. So no, I don't need beta 2, I don't need beta 3, and I don't need beta 4 because there's no f in there. They can't possibly tell me about the f slope. It's not part of their job. Okay, so now I'm down to just the things with f. What's step 2?
Oh, I heard it.
Yeah, factor it out. I heard it in a couple places. Who's throwing their voice? Someone over here. That's a talent I do not have. Let me get that. Take that out. Take that out. I am going to cheat for a moment. I don't know how to do this in, but I want some brackets. because I'm eventually going to need to put f like that. So if you do the brackets and then put the thing in, they resize so that they're the right size around the things. Okay, there. That's it. Step 3. Now you have the ingredients to figure out how to make the f-slope for somebody with whatever value of the covariates. So I'm going to come down here, make a new line. Let's go ahead and set it in the middle. F-slope equals, for someone with G of 3, H of 4, and I of 5. So I need beta 1 at a minimum, right? Because that's the f-slope. And then I know that I need beta 5 times what? The 3. And I know that I need beta 6 times 4. And where does I go? I don't go. Why don't I go? There's no place for it. I tricked you. Or I was trying to make a point, one of the two. Is the slope of f conditional on I in this model? If I go back up to the main equation here, does f interact with I as a variable? It does not. So this is the f-slope for any I. 5, 6, 7, whatever. So this is the ingredients then to make the f-slope for this type of person, in which we really only need to know their g's and h's, because that is what is moderating f. So then if I, in Stata, Lincom, I would do f, and I'm going to do the times 1, because that is what we need it to be in R as well, plus beta 5 is the interaction between f and h, and I'm going to need 3 of those, plus beta 6 is the interaction of, oh no, it's g, excuse me, this one's g. That's f and h. F, h times 4. So that's how I would get that result. In R, what's my first number? To answer that question, I have to know the entire equation again. So I'm going to go ahead and paste that down here for my reference. Okay. This is what I'm trying to estimate right here. How do I make R do it? What comes first? You would think it'd be 1, right? Because that's the first ingredient. But no, it's waiting for a value for every single spot in here. So the first number refers to what's supposed to happen to the intercept. And the answer is, I do not need you, thank you. The next number refers to this spot, which I do need one of those. So there's a 1. The next number, these 3, don't need them. Then we need this one, I need that, right? What goes here? A 3, because that's the value of the multiplier that we want the moderator for. And one more, the 4. That's how you ask for it. And in SAS, if anyone's using that, it's an estimate statement that looks just like the Lincom, but without the pluses. Same idea. Okay, so I had some folks ask me questions in the formative assessment about this. So I think, Sora, you had some questions maybe, and I told you, can you please ask during class?
Yeah, I think I got almost everything covered, and I
Okay.
just have one more left.
Okay,
I
hit
mean,
me.
in actual coding, so what you are using Lincoln F and FG,
Mhm.
like the letter, that will be the actual variable name. Is that correct?
That's correct.
Oh, okay then.
Yes.
Everything's fine. Thank you.
Yeah, I was just going with letters to make the typing faster.
Okay. Yeah.
But yes, this would be, you know, experience or enthusiasm or
Uh-huh.
whatever the name of your predictor is.
Okay.
And someone else had questions in there, I think, and I'm not remembering who that was. So if anyone else has questions that they wrote to me or that they just thought of, please let me know right now. No. Are we feeling a little better with this? Like thumbs cranked to maybe halfway, maybe past halfway? These are the ingredients. You'll get a chance to practice this part of it in your first homework then. And I will post the finished version of this when we're done today. Can we change gears a bit? Because code is boring, right? Like no one woke up this morning and was like, I really want to know how to write GLHT statements in R. Like no one has that goal. But they might have a goal to answer research questions. So let's back up a little bit and think about what the model and interpretations would look like to answer these sorts of research questions, which come from some examples of real life. So the first one, this was a question that I got over email when I was teaching 6242, the previous version of intermediate, from Solomon. Hi, Solomon, if you're listening. And I thought, yeah, no, he was like in 6242, and we were covering interactions, and he sent me an email with this question and said, is this what you were talking about today? And I said, yes, so much it is that we're going to do it in class. Thank you. Thank you for the idea.
I'll let him know we got a shout out.
So his hypothesis, so this was during the pandemic when we were stuck on Zoom, but I would argue it's still applicable in the hybrid environment. Hi, Zoomers, this one's for you. None of them have their camera on, by the way. They're like, wait, yes I do, yes I do. I'm not shaming you, by the way. It's not required. Hi. I know that not everyone.
I thought it would be distracting.
Yeah. No, it's not distracting, but I understand that there may be people in the background who don't want to be on camera, or you may not have good enough internet, or you might be in your pajamas still but wanted to show up to class. Like, these are all valid reasons to not have your camera on. It's fine. I have been known to give myself a manicure during faculty meetings on Zoom, for instance. That's the exact right kind of activity that I can do while listening to someone drone on and on about budgets and enrollments and things like that, right? So I'm not throwing shade. But his hypothesis was that camera use on Zoom is related to better course grades, but less so in larger classes. So what would a model look like, and I'm just going to write it in words here, to answer that question? Let's assume that these are all simple random sample kinds of things unless you hear otherwise. So, related to better course grades, that tells me that grades is the outcome variable. So what do I need in my model to answer that question? Sure I do. Can I type quickly, beta 0? Will you allow that? There is no equation editor in Excel, ironically. You just have to literally type the equations, but I don't have numbers, so I don't need to do that. Okay, so I need an intercept, because you always need an intercept. Very rare exceptions. What's my first predictor in the story here? Camera use. How do you think camera use is measured? Is that a on-off kind of variable? Yeah, I mean, there's no way you can have continuous camera use unless it's like the number of minutes during the class or something. But let's go with binary. So we'll say use as the predictor. How about I throw a slope in front of that? Beta 1 times use. What other variables are in my story? class size. That sounds like a continuous variable to me. Probably want to center it. Let's say, what's the mean class size at the university? In graduate classes? 15? That's optimistic, I think. There are classes of 2 people happening right now. But we'll go with it, 15. What if I left it uncentered? Can you have a class of 0? You cannot. That's as low as they will take your class away if no one signs up for it. Okay, am I done? Do I have everything that I need in my model to answer this question?
Interaction between side and use.
So you think I need an interaction? You're right. Why do I need an interaction?
Because that's, I'm not to say that, but it's more like a combination effect of the size and use. It's
Yeah.
Let's say that, decrease positive.
Yeah, so if I just had this much, then I would say that I'm allowing for camera use to be related to grades, and I'm allowing for class size to be related to grades. But none of this camera use matters more as a function of class size. Or the effectiveness of camera use depends on class size. So I'm going to throw my interaction in here with, yeah, let's put parentheses, why not? And I'll fix that set of parentheses because I am of that kind, as we've discussed. Can't leave that alone. All right. Does that look good? Almost. I need a star. There. Now, if he's right, which way do the coefficients go? I am going to copy this, and then we're going to replace the B's with P's for positive and N's for negative. How's that sound? Camera use. Do you think camera use is related to grades positively, negatively, or not at all? Positively. So is this camera use for everybody? In every class? Or is it specific, given the interaction term?
It should stay positive regardless of what we have going on in the interaction term, but it becomes less positive.
So it's specifically for class sizes of 15. We think it's going to be positive? Do this. Okay, I'm going to put that one positive. How about class size? You get better grades in bigger classes or smaller classes? Smaller classes? Which way does the coefficient go then? Okay. How about the interaction term? If camera use matters less in bigger classes, which way does the interaction term go, positive or negative? Got one vote for negative? It's sort of a democracy.
If we're centering it at 15, then yeah, it has to be negative.
Yeah, the centering does not affect the interaction term because it's unconditional. But as size goes up, we would think that the positive slope of use becomes less positive. The benefit of turning your camera on is reduced if there's a whole lot of people there and you can't even see the cameras very much. So yeah, this would be negative if he's right. I can't tell you how many manuscripts I've read where people say things like, there's significant moderation. That's it. Like that's the end of the interpretation. But in order to know if the pattern of moderation is consistent with the hypothesis, that's where the signs matter. If this were a positive coefficient instead, then that would mean that computer use matters more in bigger classes. the opposite pattern of what was anticipated. Okay. Want to do another one? This is based on a longitudinal study, but the linear model portion of it would be exactly the same as what we know how to do. So let's just do that. People receiving a new treatment decline less over time than people receiving the old treatment. So I'm going to call the outcome sickness. Actually, let's go the other way. It'll be easier if we do this. Health. That's my outcome. What predictor variables does this sentence imply?
Be 0.
I need to be 0, yep. I don't even need any predictors yet. Okay, now what predictor variables does my sentence imply? Treatment option. Old or new, we'll call it. Let's make it binary for today. We'll say 0 is old and 1 is new. What else? Time. Yeah. Teaching longitudinal in the fall, if anyone wants to figure out how to do this the right way.
I love longitudinal, it's a great class.
Yeah, and I might be able to do the advanced in the spring to make it a whole full year party. We'll have to see. My grants are stacking up and I may end up taking a buyout instead. We'll have to see. It's a good problem to have. All right. Anything else? Any other new variables implied by the question? I need an interaction, right? New and time. Same question then. If we're right, which way do the coefficients go? Let's say that time is time in study, where this is a randomized control trial. We have randomly assigned people at baseline to the old group or the new group. And that's where time 0 is. So what should be here for the group difference? Positive, negative, or 0? Now this is one where I need you to keep track not only of this idea of conditionality, but also the design. This is the group difference at what time? If time is literally the amount of time they've been in the treatment study.
At the start of the study.
At the start of the study. Should I have a group difference at the start of the study if random assignment worked?
No.
I should not. I'm going to put a 0 there. That's what I would expect anyway. How about time? If you're being treated, should your health improve? We would hope, right? I'm no doctor or anything. Oh wait, yes I am. Actually, it's Dr. Hoffman, practicing for next week. Yeah. What are you a doctor of? Philosophy. That's why I teach statistics. Make it work. Okay, so if we're right, if the people receiving this decline less, we can phrase this as, I need to go back to sickness to make it work, I think. Nope, I don't. Let's say that these are old people. And their health declines over time anyway. So this would be decline over time in the control group specifically, when new is 0. So if the treatment slows decline, what direction is this interaction term going to be? Got 2 votes for positive? Just like in a real democracy, not everyone votes who's eligible. I speak the truth, pal. Yeah, this is negative. Excuse me, positive. That was wrong. I lost the plot for a minute there, but in my defense, I've been talking for 2.5 hours, and the words start to have more difficulty coming out, and I'm out of caffeine. So I know, right? And this is like the half caffeine. This is happy medium. But anyway, yeah, we're declining. If the treatment group declines less, that is a less negative pattern that would be created by a positive interaction modifying a negative slope, making it less negative. Okay, how are we doing? Another crossover story, just for those of you who've been with me for 2.5 hours. Earlier today, we talked about the Heartland Forgiveness Scale in the factor analysis class. Now we're going to talk about the effect of forgiveness as my friend's dissertation. This is what the research question was that she looked at. She was expecting what she called a buffering hypothesis, or that forgiveness as a trait is a protective factor against the harms of the world. Stronger tendencies towards forgiveness relates to a reduced impact of stress on disease severity. In English, stress is less bad for you if you're forgiving. How's that? So severity is my outcome. What do I need first? Intercept. Okay. What are the variables in my story? Yeah, forgive. And stress. And that is my outcome. I need an interaction, yep. Otherwise, it's just forgiveness is good and stress is bad, the end. Assuming the coefficients go the right way. Okay, same question. Is forgiveness good? Do you think it makes you have less disease severity? Laura, this one's for you. Forgiveness is good for you. Negative slope means good for you. Just like in golf, where lower scores are better. Okay? Some people get mad. They're like, I don't play golf. Like, well, there are a lot of outcomes in the world in which lower scores are better for you in every walk of life and research. So yes, I'm going to say that forgiveness makes you have less severity, specifically at whatever reference level of stress this is. So let's assume I've centered it so that that's the middle somewhere. Is stress good for you or bad for you? Bad. When it comes to, there is such a thing as happy stress or whatever, but like your body still thinks it's stressful. So if stress is bad, what direction is this coefficient in predicting severity? Positive. So stress being bad for you is operationalized as a positive slope. More stress, more severity. Hypothesis that being more forgiving reduces the negative impact of stress. What direction is the coefficient for the interaction if she's right? I heard something. Negative. Want to take a vote? Negative. Less positive. That will take the positive slope and make it less positive as forgiveness increases. She called that a buffering hypothesis. I called that her dissertation. She gets to be Dr. Laura now. I don't even remember if she was right, but it doesn't matter because they don't take it away, right? You just write it up, you turn it in, and you graduate. I'm dead serious. You do not have to have significance. You just need to do what your committee said that you all agreed you would do. All right, here's another one of a slightly different form at first, but it's actually the same. This is a diminishing returns hypothesis. Spending more time rehearsing stops improving performance at some point. I'm going to say performance. What comes first? Beta 0. There you go. What's my predictor? Yeah, time spent performing, we'll say. Any other predictors? I don't think so. So am I done? If I had, this is my model, and this were positive, that would mean spending time is good for you. Practice makes perfect. If this were negative, stop it already. Spending too much time is not good. Don't rehearse at all, exactly. Just walk in and wing it.
A negative slope squared term.
Oh. So I do kind of have another variable. Is this a moderation model? I would argue that it is. Time is modifying the effect of time. A quadratic term, as you may have learned it, is an interaction term. So if I add that to my story, and more rehearsal stops helping and might even make it worse at some point, what direction is my interaction term? Negative. As time goes on, the positive slope becomes less positive and eventually flips over into negative according to this model. What if more time is initially bad for you, but then turns out to be a good idea if you do it enough? That one would be the opposite. Down at first, but then back up again. By the way, do you know what to do with this coefficient to interpret what it does? There's one trick. Some of you know this. T knows this. Vladimir knows this. Nikki knows this. I don't think anyone else has been through longitudinal, because that's where we talk about it. To interpret the quadratic coefficient, what do I need to do to it? 2! Or piece. Multiply it by 2. Twice the quadratic coefficient is how the linear slope, as this would now be called, changes per unit time. The reason for that is because there's not another predictor in here for the interaction term to modify, so it has to do its job twice. Okay.
For those of you who like calculus terms, it's also the derivative.
Yeah, that too. It's because when you differentiate with respect to time, the 2 comes down in front. So the quadratic coefficient is half the rate of acceleration or deceleration as a result. Yep. So, moderation shows up in a lot of contexts. That's why I want you to understand these principles, no matter what kind of Y you have, whether it's continuous, binary, categorical, count, whatever, and no matter what kind of sample you have, longitudinal, multi-level, etc. because this part of it is exactly the same. The linear predictor, as we will call it in generalized models starting Thursday, is exactly the same. The only difference is that it might predict the logit of the outcome or the log of the outcome. And there may be extra error terms if this is a multi-level sampling problem. But otherwise, this is the key ingredient, linear predictor. All right. Would it be useful if I put this up on the website too, the filled-in version? Why not? I have it. Like, literally, it's 3 more mouse clicks to give it to you, so sure. All right, then. Well, it's 3:12. I don't think we necessarily need to spend more time on this because all we have left were the simple slope calculations for the last model. I will tell you that your last model in your homework is going to follow this structure, except that rather than having 3 dementia groups, you have 4 golf groups. And rather than having gender as a binary moderator, you have experience as a somewhat continuous moderator. Otherwise, this is sort of the shell of how you would approach solving that set of problems. Also, on lecture 1, a 4-group example with a continuous moderator that matches your homework, not a coincidence, by the way, is on slide, find it, 24. 24 and 25. And this is what it looks like. PowerPoint has decided that class is over. This happens to me sometimes on certain machines and I don't know why. But it does this, so the key is just don't hit save. But yes, hopefully your slide 24 is a little bit more intact with respect to the equations, and slide 25 too. So, all right. Any last minute questions as we wrap up garbage day here? Zoomers, we good? Okay, well then, happy homeworking. Let me know if you need anything. Office hours tomorrow, class Thursday. See you on the other side.